Transmuting urban sprawl, Cape Town, South Africa. Cape Town is the second most populous city in South Africa, and it is the capital of the Western Cape. Located on the shore of Table Bay, Cape Town was originally developed by the Dutch, supplying ships to Eastern Africa and India. It became the economic and cultural hub of the South. Today, Cape Town is one of the most multicultural cities in the world because of its history. With an estimated population of 3.5 million, climate from 26 to 24 Celsius with mild winter and warm summer, and a land area of 948 square miles. Cape Town is actually named World Design Capital for 2014. Right now, Cape Town is walking through a socio-economic crisis, a problem which is being talked about in many internet forums, trying to recover from today's economic crisis to regain the social stabilization they once had. The main cause of this problem is the city signs of inverse densification. Large densification in red and the low densification in blue. The peripheries are densifying much faster than the inner suburbs, while the poorer areas hold the vast majority of the population. High-income areas, such as the city center, remain relatively underpopulated. This unequal layout not only perpetuates historical divides, but also excludes the majority of the population from integrating themselves productively into the city's economic and social functions. While Cape Town's social and economic development policies are focused on solving the problems of its dense peripheral regions, a better strategy is to increase residential densities in the inner suburbs to give more low-income residents a chance to benefit from the employment opportunities and services they provide. Three greater datums from the previous densification diagram were elected to project each of their mass quantification towards the less dense zones located in the city center to provide waves of possible reaction. In this case, an experimental box is used to project both the peripheral and the central datums, which spatially densify over the site by two different symptoms or rules. Above, a relocation of points of density over a planar grid represents the triangle formed by previous intersection, which then be extruded to a height depending on its basic cubic space of population. Below that one, the previous overflow represented three-dimensionally with a 90-degree angle, smoothing the vectors that join them. These interpretations emerged after a diagnosis of the analysis of the potential zones, mixed with the study of visuals and vanishing points that were specifically traced towards the south side of the site. Now, these are the same interpretations, now in three-dimensional form, with an addition of different samplers, each one relative to its own method of volumetric composition. The first one, projections, followed by interpolation, intersection, extrusion, volume, and mirroring. A very rough approach of what could be a sectional view of the different exfoliations that expect to densify and activate Cape Town's central epidermis. Another raw composition of what could be the source of energy, the source of activating dynamic overflows throughout Cape Town's waterfront center.